so here's my Can Can Soccer robot.
Award-winning.
What was that?
Award-winning.
Award-winning. All right,
Robot.
third place in the competition. All right, so I had help. We were a team. Derek, he's not here. He had the programming skills to help me get my chassis going. Really, by luck, I had this built and struggling to program it, and he was trying to get back into the group. Just emailed the group and said, anybody need help programming? And so I snagged him, and ended up being a pretty good team. Chassis. So everything was 3D printed. I custom designed it all in open source CAD software called FreeCAD, and pretty small dimensions, 180 by 160 millimeters, and pretty lightweight, only 3.3 pounds with the big 5,000 milliamp battery. So the battery's a lot of the weight in there. The good about it, the FreeCAD, I work on Windows, Linux, and Mac, so I was able to just stride right along, keep working on it. What I like about it is the robot's completely enclosed. Sensors are securely mounted and recessed, so wires aren't exposed. Everything is real, I mean, inside it's a mess, but at least it's not going to get snagged on anything, or the wires are out of the way. But the bad thing about it, I spent a lot of time in the CAD software. This design doesn't allow me any flexibility with my sensors. I mean, once I designed it and I printed it that way, it's done. So I wanted to change it one time, had to reprint the whole sides and everything. So that was a drawback on it. And it's pretty light. As soon as we bump into anybody, we were off course, and we couldn't hold our ground for anything. And another thing is that the wheels are exposed. I didn't like that design because it's easy to grab onto something as well. Just almost miss the other robot or the wall, and it grabs that, and then it just tries to run up the wall, and it gets out of control. All right, the mechanics. So I'm using some Palalu motors in there, probably more power than I need. They have some encoders on there. So they have a 6 amp stall on it, Bainbot wheels, 2 3/4 or something diameter, and then a Palalu caster in the back. So what was good about it, the motors were real powerful. The wheels were kind of narrow, so it helped me get good odometry. But there was a lot of amps on there on the wheels. But fortunately, we were on smooth surface, so the wheels would actually spin before they'd stall out. So I didn't have a problem with the amperage. And then I really don't like the ball caster design. There was cracks and grout grooves, so the ball caster, you got to get in there and kind of tweak it a little bit. And then outside of that competition, if it's on a carpet or inside of a building, it's not designed for multiple surfaces. Any small object, it's not going to be able to go up over. It's just going to snag it and get in the way. So I'm really looking for some sort of design that will get rid of that caster for me. The electronics, so the brains of it was a Teensy 3.1. So it's got an ARM controller in there, 96 megahertz. So I have plenty of processing power for everything I needed to do. Plenty of memory. We did end up surpassing what a regular Uno would do, so it was good that I had enough memory to accommodate that, and a lot of I/O lines. So that helped out. I was using a Palalu motor controller, and you can see this could only handle 3 amps per motor, and my stall was 6 amps per motor, so good thing I wasn't pushing it that hard. But also, that was 6 amps at 6 volts. 6 amps at 6 volts. While I was running it all through a regulator, which was 5 volts, I was bringing down the voltage of the motors, and then that regulator can handle 7 amps. So, the good of it, I had lots of I/O, plenty of processing, and a consistent regulated power. One power source for everything. That might be a good and a bad. I got it listed over here on the bad side as well as possibly bringing some noise on the bus and maybe affecting me that way. I didn't know for sure. I didn't have a scope or anything to look at the bus to see how it is. And then the teensy is not easy to access all the I/O lines. Some of them are on the bottom, they're surface mount, so I just surface mounted some wires directly onto it and soldered a breadboard and just drew out my pins that way. And then, of course, I mentioned that my motor driver was not powerful enough for the actual motors that I had. The sensors on there, so mainly we're running a lot of IR sensors. 3 of them are the 10 to 80 centimeters. They face forward in 3 different angles, straight, and then 45-degree angles off each side. And then the 2 bigger ones on the side mounted can read 20 to 150 centimeters. And then we also have some sharp infrared bumpers that run around the side and to hopefully help with some obstacle avoidance. But that didn't work out too well. And then the Maxbotic sonar, and that was also using that for some obstacle avoidance. And go to the right place. So we got pretty good accurate distance readings, and I liked having a 45-degree angle fixed shell, so I knew exactly where those sensors were pointing to and what they were reading, because we used we would do the calculation of where an object is based on the angles and calculate it back to the center of the robot. So not having any swivel in that angle helped me pinpoint the objects a little bit better. And the bad side is those sharp infrared sensors have a really narrow beam, so you can potentially miss objects. And then, as we saw, we wouldn't find objects all the time. The interference from the sunlight and other light sources, so we got inconsistent readings from that. And some of that could have been my power bus as well. Again, I don't know all the details of what was going on there. So our strategy was odometry. So that was, we had pretty good odometry. We knew the whole layout of the arena. We knew when we got a can, exactly where we needed to go to get to the goal. And we detected the cans. We put them on a grid. So when we found a can, we're driving forward, and as soon as we saw a change in the reading, we knew where the wall was if we were reading the wall, so we ignore that. And then all of a sudden we'd get a shorter range. Okay, there's an object, so we'd start counting how many times do we see an object in that range, and then boom, we went past it again. So the object. So then we would calculate we knew the pinpoint of that object, and we would calculate where we saw it start, where we saw it end, what's the width of it, does that look like the size of a can? If so, that's a can, store it up. So all that took a little bit of time. It actually allowed us we have multiple sensors. We could find maybe, if they were positioned in the right place, we could find 3 cans at the exact same time, and we would store those in an array. So we knew this can was here, this can was there, this can was there. We'd go to the first one, the closest one to us. After we got to the goal, we already knew where 2 other cans were. Potentially, we could drive right back to them. Didn't always work out that way since the cans were spaced out, but that was the plan to attack that. And we drove a set pattern. So we just said, all right, we're going to drive to the middle, drive to one of the corners, come back, and just do a pattern that we knew would cover the whole ground, so the sensors could find a can in pretty much all the locations. So our odometry was pretty accurate. We could go multiple runs, make even running by ourselves a whole 6-can run. We could go get cans, take them to the goal, and take all 6 cans there, and still have pretty accurate odometry. The pattern gave us pretty good detection, and again, we were able to find multiple cans, but we were too dependent on odometry. All right, slightest bump, anything happened, we were done. We had it in our plan to program how to relocalize, but we didn't get there before the competition. So we could run great by ourselves, but when we had to go head to head, we had problems. We had too many false positive can detections. So we were pretty good at finding a can, but then could also drive right past it and miss it. So it was hit and miss. One more slide. What I would do differently. So what I would do differently, I'm working on another prototype it's more modular. So if I want to change out a sensor, I can just unscrew that piece and then screw it back in and go to a different infrared sensor, different sonar sensor. I've got some bumpers on here so I can tell whenever I'm going to bump into some, or when I've collided with something. So that's really important, is knowing when you run into the other robots, so you know you need to relocalize. And
so everything is like screwed into strips.
yeah, I've got post going into the I got post going into it, and then these are set panels, and then just
your space holes.
Yeah. So this is prototype of the design I'm working on right now. I'm also thinking of probably moving the motors underneath it, clearing this out, and giving me a little bit more clearance. But wheels are in set. Protect them a little bit. So.
How did you pick up a can, or did you just push it?
No, they have the. I guess I didn't cover the servo. Yeah. So I've got a gripper controlled by a servo, so it would stay open, and the infrared sensor would let me. I would go to where I knew the can was, close on it, and then after I closed on it, this infrared sensor was either high or low, telling me that there was an object in the grippers. The downside with that is when I ran into a wall, when I thought a wall was a can and I went to grab it, I grabbed it, the sensor said, yeah, there's something in there, so my grippers were actually empty and I'd take an empty can to the goal, so there's a downside to
But
that.
as you run away, would you then realize that there was no can?
No, because I didn't keep checking it. I didn't want to, I would validate right when I closed the grippers, and then didn't want to just keep checking it all the time.
So you
Seems like maybe if you validate right after you make a turn.
Yeah, that would have been a good.
So you mapped out where the cans were first, and then got them, didn't you?
No, I went one can at a time, and it just, if I saw multiple cans, I would map them out, but I would still grab the first can that I did. It was just on a short delay, like every 500 milliseconds, I would choose a can to go to, so within that 500 milliseconds, I could have found 3 different cans. We were polling the infrared sensors every 40 milliseconds, so Ron really helped me out on that, because I was having a lot of problems with consistent readings, and I was polling it as fast as I can, trying to do some averages, and it was just, really inconsistent. And he said, I don't think you're supposed to use those guys more than every 40 milliseconds. So then I quit even I just take one sample every 40 milliseconds, and it was a lot more accurate. And I would just use that reading instead of averaging multiple readings together.
You're gonna be away for